Hi and welcome to our pre-calculus topic. Today is proving trigonometric identities using sum and difference identities, problem type 1. So here is the sample question. We want to show that if we take sine of difference of two angles plus the sine of sum of the same two angles, what we get is twice the sine of x cosine of y. Okay, we are going to show this thing here, and then you are going to see many applications of this thing later on in calculus, differential equations, and elsewhere. So what do we need? We need our identities for sum and difference. Let me just remind you of these identities we had. Sine of x minus y was sine of x cosine of y minus cosine of x sine of y. And in case you had a sum, here you will have a sum as well. You have cosine of x, again say plus or minus y is cosine of x cosine of y, then it's minus and plus sine of x sine of y. Then we had also tangent of x plus or minus y. This was tangent of x plus or minus tangent of y. 1 minus and plus, so it's down here opposite order than up here. Tangent of x tangent of y. So in all of these cases, top goes with top, bottom goes with the bottom, and so on. We are going to use these things repeatedly to get what we want. And the very first exercise that we are doing is the first case. Let me rewrite it again. Sine of x plus y is sine of x cosine of y plus cosine of x sine of y. And then sine of x minus y is the same thing, minus cosine of x sine of y. So what that identity is asking us is that what if I take these two and add them up? Add up the two equations, so you get sine of x plus y and then sine of x minus y. Out comes what? 2 sine of x cosine of y. Right now this looks like a mathematical manipulation, but later on you are going to see applications of this to issues as far-fetched as resonance and problems of that type that occur both in ordinary differential equations and as well as in physics. And you're going to see this identity in your calculus classes as well. So a very applicable, useful idea. Okay, so what we are here, what we are doing here is trying to find our way. When it says select a rule, notice that now we have a few more rules than before. We have sum and difference, which is what we have been studying. Double angle is going to come up next, not there yet. Odd and even, we had a few chances of using them, and the other ones are old ones. So here you're just using sum and difference, where we are going to write just what I wrote: sine of x cosine of y minus sine minus cosine of x sine of y, and then we add to it the second piece, which is plus sine of x cosine of y plus cosine of x sine of y. So we expanded we expanded this one and that one, and I wrote what I will get. Let's see if the software is happy with that. Okay, now we are going to apply just algebra. This term and this term cancel each other out. Is that right? So all that happens from here on, this and that, minus and plus cancel each other. These two are identical, so all I get is twice 2 sine of x cosine of y. Okay, so this term is same as this, so we get 2 of that. The other two were identical, one positive, one negative. They cancel each other out. All of that activity is just algebra. And are we there yet? So software is happy with our actions. Let's see if there is anything. This looks like just what we did. Okay. So we are going to do expansion of the numerator. Okay, we have sine of x cosine of y minus cosine of x sine of y. Denominator is cosine of x cosine of y. Okay, so what did we do? We applied sum and difference. Validate. Next, we are gonna take this fraction and split it into 2 pieces. So let me just write it for you so that you see what's happening. So what did you have over there? We have sine of x minus y over cosine of x cosine of y. Let me make sure I remember this correctly, that is what we are doing. Cosine of x cosine of y, yes. So we said this is sine x cosine of y minus cosine x sine of y divided by cosine of x cosine of y. Now, a very basic idea: if you have a fraction, the numerator being several things added up, you can split it, opposite of taking common denominator. Okay, if you have a plus b over c, obviously that's the same as a over c plus b over c. What am I expecting to happen is that this cosine will cancel, this cosines will cancel, and we get what we have coming up. So first I'm going to split my fraction. So sine of x cosine of y over cosine of x cosine of y minus cosine of x sine of y over cosine of x cosine of y. So that is this simplest kind of fraction decomposition. Then cosine cancel, this cosine cancel. So I have, so that is this activity will be algebra. So from here to is algebra. The simplification is also algebra. Now I'm going to write sine over cosine. Well, that is tangent of x, and this is going to be tangent of y, and that's of course the ratio identities. We are applying ratio identities to do that. So now what is left is to actually do it here. So probably we can combine all of our algebra in one step, but just to be a bit pedantic about it, sine x cosine y, denominator is cosine x cosine y, minus another fraction. I have cosine x sine y in the numerator and cosine x cosine y in the denominator. What are we doing? Just algebra, nothing else. Validate. Now cosines cancel, so here you cannot rush too many things all at the same time. Another fraction. So what's left? Sine of x over cosine of x, then minus another fraction. Now cosines cancel. I have a sine of y over cosine of y. We are doing against just algebra. Validate. Now that is tangent of x minus tangent of y, and that is our quotient identities. Is that right? And that's what's on the right hand side. So problems here are of this type, and I'm sure you can do them quickly and successfully. So until next time, good luck and God bless.